All right. So again, we're going to start with justifying, and every step, we're not going to assume anything. When we prove something, we prove it from beginning to end. So unlike the first side where we were just concentrating on those properties of equality, this one's going to be every single property is in play now. So let's talk about this very first one, which seems very easy, and it is as far as the equation goes. What would my first step be on this equation? It would absolutely be to subtract 4 on each side. What property says that's okay? The subtraction property of equality, which we commonly refer to as the subpo in this class. Now, here's where it's different than your other side. I can't just cancel these out. That doesn't prove anything. That's what you've been doing for years. And that's fine when you're solving. But when you're justifying, you can't just get rid of stuff. You have to prove why it happened. So I want you to think about this. What is 4 minus 4? So this is x plus 0 equals negative 2. To get from here to here, you told me that 4 plus a negative 4 equals 0. What property tells me that? Additive inverse. So that is your justification. So to get from where I subtracted to where this is a 0, the property that told me that I could do that is additive inverse. Now, we never look at x plus 0, and we normally don't do this step, right? Normally we just say x equals. But I wanted you to see in between that's a 0. Now, what property tells me I'm going to then say x equals negative 2, so I'm going from here to here. What property tells me that x plus 0 equals x? Which identity? That's exactly right. Additive identity. And I'm done at this point. So if you'll notice, I didn't just use my property of equalities. And you're like, okay, that's why that works. I'm not just canceling out. We're past, oh, remember to keep things on either side of the river. Like, you'll still hear me say it when we're solving, right? But when we're justifying, ain't no river, it's an equal sign, right? And there's a mathematical reason it works, and now you know the names for this. This became a 0, and 0 added to anything is that thing. Huh? So when you added additive inverse, it became 0. And then 0 added anything became that thing. So the red was just saying how I got from here to here. I was saying x plus 0 is x, and the thing that tells me that is additive identity. Good follow-up. Yes? Oh, so let me explain what I'm putting to the side here. This is like my thought. So because this was confusing to some students when to do which step. So what I did here is I subtracted 4. Subtracting 4 on each side, that very act of subtracting is the subtraction property of equality, right? When I say that 4 minus 4 is 0, or 4 plus negative 4 is 0, what got me there was additive inverse. Anything plus. So this is my thought. That's what I did to get to here. And if I did that, that means I did the additive inverse. So on the red one, and you don't have to, I'm glad you said that. So this little stuff over here was my thoughts. This is not required. Only what's in the table is required. Okay? This was so you saw that this was my thought process of how I got from one to the next and why it's that property. Yes, ma'am. You do not, because that's you could, but I think it's going to be confusing if you do. Remember that on our examples, they put it on either side of the equal sign, but all of us were like, that's not how I do it. Like, I understand how you did it, and that's fine. I don't like it. Let's try another one. I want to do the one right below it. All right. Again, this is a fairly basic one. So we're going to start, but it's also going to be another thing of where you've done something and you've assumed something, and it's fine when we're solving, but when we're justifying, we're not going to. So looking at 5x equals 12, what is my first step? Divide each side by 5, and that is the division property of equality. Now here's where it's going to be a little bit new for you. And this particular step confuses some students, so I'm going to put my thought process over here in just a second, all right? So, rather from here to here. So that's going to give me 1x. I can't just say x. 5 divided by 5 is 1 equals, and we can leave that as a fraction or you can call it a decimal, but I'm just going to leave it as 12/5. I would take it either way on a test unless I was specific, right? Unless I said leave it as a fraction or unless I said leave it as a decimal. Most of the time, I won't be specific and I would advise you to leave it as a fraction because it's less likely for it to be wrong. All right? Now, this is the one property that I kind of let you get away with if you forget this step or forget which one it's called, because to me it's the hardest one of any of them. But look at what's really happening here. What you really did is you said 5 times 1/5. That's what you did to get from here to here. 5 divided by 5, remember we can't divide fractions. And when you divide fractions, what do? You flip the second one and multiply. And what tells me that a number of times it's reciprocal, right, KFC? What tells me that a number of times it's reciprocal is 1. The multiplicative inverse. Multiplicative inverse. Now, my next thing, and again, I'm just showing you my thought pattern here, is that I know that 1 times x is x. What property tells me that? Which identity? Multiplicative identity. So now I say x is 12/5 according to the multiplicative identity, and I'm done. All right? We're going to do a 2-step one, and that's going to be the last one I do from this video. If I get a lot of comments on the blog or through email or whatever of wanting to see a couple more, I'll be glad to. All right? I will take the time to do that. This is really important. And so we're going to do a 2-step one, and we're going to put it together. By the way, if you've noticed, you may have extra lines sometimes. All right? So, and there's a couple on them. I didn't give you enough, and I'm sorry. You know who we'll blame later when the video's not on. All right, so let's start then with this one down here. Let's do 2 more, just because we're on the video. So let's do 2 more. Let's do this one right here. All right. So, yeah, we're doing okay time-wise. 12 equals 5x minus 10. What let me do that? The distributive property. All right. I distributed out the 5. Now, what should I do next? I should look to see if there's any like terms to combine. There weren't here, so what's the easiest thing to do? If variables are already by themselves on this side of the track, add 10 to each side. Oh, what property lets me do that? The additive property of equality, the ADPO. That's going to give me 22 equals 5x plus what? Good. I didn't change colors there, but hopefully you're following me. And what property told me that negative 10 plus 10 is 0? Nice. Additive inverse. And from there, I'm going to then say 5x plus 0 is just what? What's 5x plus 0? 5x. And which one is that? Additive identity. And you can see how I'm abbreviating, right? And I'm very fine with you doing the same. So what then would I do? Divide each side by 5. And what lets me do that? The division PO. All right. And that's going to give me 1x equals 22 over 5. What property tells me 5 times 1/5 is 1? Multiplicative inverse. Some people said they kind of see the pattern where inverse always comes right before identity. And it does. All right. And so then what is 1 times x? X equals 22 over 5. And what let me do that? Multiplicative identity. And this last one is one you've been doing for years. We're then going to say x equals 22 over 5. Does anyone know? It's not a property. Actually, it is a property of equality, but not one of our traditional ones. Which property said we could do that? Nice. The symmetric property. It sure was. It absolutely was. That should give you a really good start for tonight. So we did the first three on the first column. I'm